I believe, my fourth video now, and this will be covering stacks and queues, so some of the cool stuff that we learned in this unit, in this part of the class, and then we'll talk about infix, prefix, postfix notation, some stuff that you might want to know to go into the test. And then we'll just talk about some other stuff just to wrap up, and then we can talk about what's at the bottom of this page. Great. So once again, we're going to follow on this review because it has a lot of cool things that we talked about. So yes, I do want to reiterate, again, this is multiple videos in now. Just want to reiterate, test is comprehensive, so know the concepts from the previous exam, and remember to look over string and list manipulation. Stuff like that you can do with stacks and queues. Also, remember how a simple class is defined. It could be very helpful when you are looking at a stack implementation that we may give you or that you may have to create yourself. And so those are two things that are very important for you to know. Besides that, in the past two videos, I covered hashing and recursion, and we can talk, and big O as well, and we can talk a little bit about that, and then we can do a little wrap up with everything else. Okay, so let's get started with stacks. And so I'm just going to open this Geeks for Geeks page, and this is where I think the best pictures and the best understanding come from. I can give you a little quick explanation of what's going on with stacks, but if you are more confused, I definitely recommend checking Zybooks out and this as well. There are videos as well to help you figure things out. So let's begin with a stack. A stack is a last in, first out, or first in, last out data structure. And what that means is that the last thing that you put in will be the first thing that you can take out. And so that's kind of how stacks work. And I think the best way to think about a stack is like a stack of dirty dishes, maybe a stack of papers. You can't just kind of insert into the middle without having some sort of difficulty. And so that's kind of what a stack represents. And this picture is pretty good at telling us what's happening in stacks. Now, the stack class, at least is what we're going to be providing you and what you may see out in the wild, will consist of a couple of functions. The first function, or the first method, will be push. Pushing means that you're putting something into the stack, and as you can see right here. Then the next method is pop, which will take something off the stack. And you may have heard me talk about pushing and popping off and on the stack from the last videos in which I talked about recursion. And recursion actually has this thing called the call stack, and it's very similar to this data structure. And we can use this stack to do a lot of things that recursive functions can do. So you can kind of emulate a recursive function on a stack. It's pretty cool. So the idea is that you're going to be pushing your pop, and then we have another method called peek, or sometimes you may see it as top. And that's going to get you, just going to let you see what's at the top. This doesn't remove it, whereas pop will remove it, and push will put something on top of it. Peek will let you see what's going on at the top of the stack. And then finally, you may have this method, which is empty or empty, which tells us whether the stack is full or empty, etc. And so that's usually a Boolean. Now, stacks in our class and in Python and in a lot of different languages, they might be implemented with a list or an array or some sort of data structure. But you can't always say that they are in list form. They could be written in something else or in a different language altogether. That prevents you from accessing the underlying data structure, the underlying list that the stack is written in. And so that's where the biggest problem comes in, because now you have to use the stack push and pop methods. And stacks are wonderful data structures. So again, you can look at all the different stack classes, and we can go stack in Python, and this will show you how the implementation works. But I just want you to get sort of a brief understanding of what's going on, and then just some I guess resources that can help you. I would say some of this implementing a queue or implementing a stack with a queue, those are some cool ways for you to understand your how well you know stacks and how well you know queues by implementing them with each other. Past that, I think one really important example is checking for balanced parentheses in an expression. This will help you learn how stacks work and what kinds of capabilities we have that go past the capabilities to simplify questions that you could use a list in, you could use a stack for as well, and it's pretty cool. And so I definitely check this link out. It will really help. As for moving forward, again, this is kind of saying what this is the same problem type, and you can read more about this. Um, let's move on to the next thing, which is a queue. And so a queue, I like to think about as a queue at, I guess, a restaurant, like a fast food chain, or a queue on your Spotify playlist, for example. And so queues are pretty great. Again, you can read this up on Zybooks, and I'm just going to give you a quick overview that should get you introduced to what a queue is in case you have forgotten. So in a queue, you have this thing called, it's basically just a line, right? And in a line, you can only see the front and you can only see the back, right? You can exit from the front and you can enter from the back. You can't cut people in line, right? This is a good line, right? You're not cutting anyone. And so that's the idea. And so if you're not going to be cutting anyone, then it's best that you just enter and exit from respective locations. So in order to enter, you call this thing NQ, and this NQ is to the back of the queue. So you enter the line, and then you DQ from the front of the queue. So you enter from the back and you exit from the front. And this is kind of like the opposite of a stack, and it's in that it's a first in, first out. So the first person that comes in is the first person to leave. That's great. We also have a peek method in here as well. You can peek at the front, and you can see the length of the queue. Again, this could be written in as a list, but you can see where the issues with the list come about, right? Removing from the front or adding to the front causes you to shift over all of the data that's already in your list. And that could be a big O operation of n, right? Of n things in this list, you're gonna have to shift all of them over, right? And so that's n shifts. And so you can see writing this with a list is sometimes not the most efficient way of going about it. You can use something known as a linked list, which we discussed in class, to also help you. And then there are different implementations that can actually improve the efficiency of the queue, and that's kind of the idea of queues and stacks, is to have that sort of efficiency. Now, we talked about all the different things about the queue. Let's talk about a cool problem that you may have, which is like sum all the values of the queue without using an extra data structure. And that means don't use another list, don't use another thing, and return the queue back to how it needs to be, right? So I want to get the sum of this, but I want this queue to remain itself, right? So we can actually, for these types of problems, we can enqueue some sort of marker, a marker that's somewhat different to the rest of the queue's data, internal data. And we can be like, okay, this marker, if it's a bunch of numbers, we can say, okay, let's put in a number that doesn't match the rest of them. For example, if it's a bunch of positive numbers, we can put a negative number in there. Or we can put in a string or something in that, something like that, so that we know that, okay, we can't add this, and we won't have to, we'll know that that's when the queue stops. So then you can enqueue that at the end, and you can dequeue and enqueue. So making like a kind of a circle, right? Making a circle. And you can enqueue over here, enqueue over here, and then dequeue over here, and then enqueue back over here. And then when you get to that marker, whatever it may be, then you'll know, okay, I've reached the end of the stack, end of the queue. And that's how you can, and then as you go, you can just keep track of all these additions. And so that's one of the cool examples, or one of the cool problems that you could solve with a queue. Pretty cool, right? Queues are also useful for like this thing called a priority queue is useful for like figuring out who's next in line, who should be next in line, and things like that. Also, in the future, in the next few assignments, when we get into graphs, queues will be very useful for BFS and then things like that. So keep queues in mind, and again, you can read more about it on Geeks for Geeks. And then one quick thing that is often asked is, how do we reverse a queue? And so in order to reverse a queue, we would want to take, and this you need to have another data structure, right? If you just enqueue and dequeue, you just get the same queue. So what you would want to do is you'd probably want to put it into a stack. Okay, so you want to take one of the objects, right? So you want to take this thing, dequeue the beginning one, put it into a stack, and that will cause it to be at the bottom. And then you dequeue everything into a stack, and you enqueue from the top of the stack. And then this thing, which is the last thing to go into the stack, right, will be the first thing to go into the queue. Does that that should hopefully make some sense. If it does not, again, there are ways, there are standard problems that you can look at. And this here it is, reversing a queue. and then you can do it with recursion and stuff like that. So it's a pretty common problem, and I think you should look at that as well. So yeah, we covered real quick the things that we covered, and again, I will link these pages and the link and everything below. The things that we covered in this video were stacks and queues, and then how to like balance the parentheses, which is a problem that I'll let you guys look at and see if they're balanced correctly. Let's go, before we move into, before I end the video, let's talk about prefix, infix, and postfix notation, and which are very useful when you using a stack in order for evaluation. So let's move into here. And so prefix, postfix, and infix, I'm just going to open up this link over here, and you can see exactly what prefix means. But the idea of infix, the idea of these conventions for adding and subtracting and multiplying and all that is that you want to avoid using parentheses, because parentheses sometimes aren't that great. They may not be super pretty, it may be a little confusing, and it may just be problematic for computers to like kind of parse through parentheses, right? So sometimes you don't want to use it, and so so our regular 1 plus 2 plus 3 plus 4, whatever, right, is known as an infix notation, right? So you can see that the numbers are surrounding the little the operator. So that would be like the plus is in between, and that's why we get that infix. Now you can kind of start to extrapolate what prefix means. Prefix means that the operator, that plus, that minus, is going to be before the rest of the math, and the postfix will be after the rest of the math. And let's open up this and we can kind of see a picture, a little visual representation of what's going on. So over here you have A, B, and so this is prefix. So you're wanting to do, and you want to take the first value right here, this plus, you want to move that straight in between, right? Because you want to convert it to infix. So you're going to do A plus B, and then you're going to move down here and you're going to say, because this is the next thing closest, right? C minus D, right? So you want to just keep looking at the next thing closest, and then you want to finally take this, because it's going to be it's going to be the last operator, right? And you're going to put it right in between. Cool, right? And you can do something like this, which is like, okay, this, where does this go? So first I'm going to divide, right? So the first thing I'm going to do is I'm going to divide A by K, then I'm going to minus that L, then I'm going to take B divided by C, then I'm going to minus that A minus the B, and then we're going to take that times, and we're going to put it there. So you just got to look at, and I guess the best way to look at a prefix is just look at the thing right before it, right? Like reading left to right before the number, right? Right before the number, as you can see, right before the number, and then dump it in between those two numbers, the two numbers right after it, right? And then you'll see that this becomes like a new number. This becomes a new, let's say this is like a new number. And so then we're going to say, okay, let's take the next thing, right? That minus, and it's going to be between AK, or A divided by K, and then L, right? So that minus is going to jump right there. So that's kind of the best way to look at it. And then you can use stacks to actually compute the value. So if I put in some real numbers, you can actually compute it, and then it's going to show you over here how this kind of works. All right, and let's jump into postfix, which is very, very similar to postfix to prefix to infix. Again, it's at the end. So again, this time you're going to look at this number and this value, this operator, you're going to put it between these two numbers, the ones closest to it, and then the next one over. And then the same idea over here. See, there's nothing to put between these two, so first you got to start over here, put it there, and so it's like just backwards. But I guess you guys should understand that from this, and then again, there are other tutorials online to help you out with it. Okay, what's next? So we covered infix, prefix, postfix, and those are useful. If you want to evaluate postfix, you can use a stack, and you just know how to convert between the three of them. It may help. It may also help you learn about stacks a little bit better. We talked about queues. We talked about how to get the addition or traverse a queue without destroying it, which is by placing some sort of marker. Then we also talked about determining parentheses, and that's very important, and that's something that I'm going to leave up to you guys to learn about. And we covered all that, and so now let's move forward and just talk about this bullet point in which we're basically saying that you may use your notes for this test, but you may not, so this is incorrect, you may not run your code on your computer to test it, okay? And you may not communicate with another human being other than the TAs, that's us, through email. So just a foreword on that. So just don't do that because we can tell when you are copy pasting and stuff like that. So we just don't want you to do that. That gives you an unfair advantage because this would not then reflect how a regular test would be, like an in-class test would be. Great. Then below here, there's some things that you can look at to kind of help you figure out how these recursive functions and stuff works, and then you can talk about that on Piazza or whatever. And then this is a permutation and a combination problem. Again, we mentioned that in the last two videos. So I will call it a day on this one. All right.